Hi students, this is section 6.2, multiplying and dividing rational expressions. So let's get started right away. First, we have a problem that says simplify the rational expressions. And what operation do we have here? We have multiplication here. Because of this dot, you know that we're multiplying. But we're not actually multiplying. What we're doing is we are factoring first. And then we're canceling common factors. So that's what we're going to do for these particular problems. For example, A, we have all of these polynomials. Are any of them factorable is the question. So identify what is factorable. Is 3x plus 6 factorable? Is x squared plus 4 factorable? Is 5x factorable? Is x squared plus 10x plus 16 factorable? So I would say factor everything that you could factor right now, and then this is going to help you with learning how to factor for the factoring test. Okay, so pause the video, factor everything you can factor, and let's see if you got it right. So if you factored 3x plus 6, you were right because it's 3 times x plus 2. Because there was a GCF there, you had to take that 3 out. Now x squared plus 4 is not factorable. Why, you say? It's a sum of squares. A sum of squares is never factorable. We can't do anything with the 5x. But that x squared plus 10x plus 16 is a trinomial. So we're going to factor it. We have our x's here. We need factors of 16 to add to 10. So it looks like 8 and 2 will work for that. Now, always check your answer by multiplying, distributing, foiling, or multiplying, okay? To make sure that you factor correctly. Now I see that x plus 2, the x plus 2's cancel. Nothing else actually cancels here. So what you're going to do now is just write down what's remaining. And your final answer would be 3 times x squared plus 4, because that's what we have in the numerator, divided by 5x times x plus 8. That is the final answer for this problem. Let's move on to the next problem, B. So in B, we have 7x minus 21 divided by x squared minus 9x plus 18 times x squared minus 4x minus 12. And factor everything that you think you can factor, and then write it down before I reveal the answer. Now, if you factored 7x minus 21, then you are correct if you factored it as 7 times x minus 3. Now, notice to the right here, we have a trinomial, but it's understood to be divided by 1. So you can always write that 1 in the denominator. Now, x squared minus 4x minus 12 is an easy case trinomial because the leading coefficient is 1, so you don't have to go through the AC method. So now we need factors of negative 12 that add to negative 4. So factors would be 6 and 2. And then you have it would have to be a negative 6 and a positive 2 to get negative 4 when you add those. And then x squared minus 9x plus 18. So x minus 6 times x minus 3 will work because negative 6 times negative 3 is positive 18. But when you add them, you get that negative 9x that you want. So now, since everything is factored completely, you could cancel. Now, what do you see that can be canceled? And that's the main reason why I have this little bubble over here. You probably was wondering. This is multiplication, right? And a lot of people think that you could only cross cancel, but that's not true, because notice that we have a k over k situation here. So if they are right under one, or above and beneath, if the common factor is right vertical and not diagonal, it still cancels out, right? K divided by k is 1. So the final answer is A over B here. It doesn't have to be A over K times K over B to cancel, because the answer here would be, it would still be A over B. So the answer here would be A over B, regardless of if the K was diagonal or vertical. So let's move on to C. Go ahead and factor that as much as possible, and then you could reveal the answer. So x squared minus x, and some people think that's a difference of squares. X is not squared here. That x on the right? So there's a GCF though that you can pull out. X times x minus 1 would be the factor for that. We're going to rewrite the x plus 5 and then factor to the right here. We need factors of 4 to add to 5. So x plus 1 times x plus 4. Now x to the 4th minus x squared. A lot of people will just go right for the difference of squares. But recall what the first step of factoring is. It's to take out the GCF. So we must do that first no matter what. We must take out the GCF no matter what you see. Okay, you think it's a trinomial or a difference of squares, if it has a GCF first, that step is always first. Now notice here though that we haven't factored completely just yet. So let me rewrite everything back over. I know that's tedious to rewrite everything back over again, but it's organized, so let's go ahead and do it until you get really good at this and you don't have to write the whole thing back over. You could have just erased what I had and I highlighted in yellow, and you could have just replaced it with x plus 1 times x minus 1. Now let's take out some common factors. We see that x minus 1 can cancel out with x minus 1. You also see, like that k over k, that x plus 1 divided by x plus 1. And again, all of this is 1. We're not writing the 1, but 1 is there. That's very important that you know that a 1 exists there. Even if we didn't write the 1, a 1 exists. I also want to show you there's one other thing that could be canceled here or reduced, and that is this x with this x. See this x and this x. So there's an x in common that we can get rid of, top and bottom. So I'm going to get rid of this x, and that will leave us with 1x down here. So our final answer, what's in the numerator? Well, we still have an x plus 4 left in the numerator. And what's left in the denominator? You have an x plus 5 times x. But it would be better if you wrote it as x times x plus 5. So that's the final answer for that problem. Moving on to D. We have x squared plus 10x plus 24. And notice here, definitely need to pause, because that's a division symbol. So if we know anything about division, if you had A over B divided by C over D, what you'll do is keep, change, flip that. So keep, change, flip. Meaning what you do is rewrite A over B. You want to keep that the same. You're going to change that division symbol to a multiplication symbol, and you're going to write the reciprocal of C over D, which is D over C. And we say flip for short, but D over C is the reciprocal of C over D. So then that's when you multiply across AD over BC. So that's the same thing we're going to do for rational expressions. So this is, of course, over 1. So let's rewrite everything back over. We're going to keep this as the same. We're going to change. So times, and we're going to flip. So here we have x minus 5 over x squared plus x minus 30. Now, we have a trinomial, and that would be factors of 24 that add to 10 would be 6 and 4. So that was pretty simple. We're going to rewrite x minus 5 back over. But now we need factors of negative 30 that add to 1. Why 1? Because it's considered to be a 1x in the middle there. The b is considered to be 1 in this case. Now, factors of negative 30 would add to give us a positive 1. So if you said x minus 5 times x plus 6, or x plus 6 times x minus 5, then you are right. So what cancels? Well, definitely the x minus 5's cancel. They are right under each other, above and vertically. That cancels because that's like x minus 5 divided by x minus 5. And what is equivalent to when you have the same thing? You're dividing by itself. Just know there is really 1 there. And then you have an x plus 6 that you cancel. So really the only thing that's left over or remaining in this situation is x plus 4. Please don't write x plus 4 over 1 because that's not simplified. Like if I ask you how much money do you have in your wallet and you said $5 over 1, it doesn't make sense to put it over 1. Just say 5, right? That's the most the simplest way of saying that. So x plus 4, don't put x plus 4 over 1. If you do, go ahead to the next step and say equal x plus 4. Now e, this is the last one in this section. So what we're going to do first is rewrite everything over. This is again division here. So what you need to do is read out. I know it's tedious, but rewrite everything back over. We're going to keep. Next, we're going to change, and we're going to flip. Now again, we can't cancel terms, as you know already. So we have to factor this. Now in this case, we have a trinomial, but guess what? These trinomials are not, don't have a leading coefficient of 1, so you will have to perform the AC method. All right, so for example, and I'm not going to do this for all problems, okay? I'm just going to do this for, let me do the bottom one over here. 2x squared plus 5x minus 12. Yeah, let's do this one. AC method says that we must multiply the 2 times the negative 12. We get negative 24. And we want factors of 24 first, but then we decide on the signs, right? So we go through the motions of writing out all the factors, and then we decide what will add up to give us the 5, right? The B here. But at the same time, we'll multiply to give us negative 24. So it has to work both ways. You it can't add to be 5 and not multiply to be negative 24, or vice versa. So it looks like if we just put a negative in front of that 3, make it a negative 3 plus 8, we will get the positive 5 that we want. But at the same time, we will get negative 24 when we multiply it. So when we rewrite our trinomial, we could put negative 3x plus 8x here and rewrite the last part C, and then we group. You can take out an x and you can take out a 4. So the factors are 2x minus 3 times x plus 4. for that particular one. So what I want you to do is factor all of the rest of the polynomials. I'm gonna go ahead and put the factors for the right fraction, which the factors are 2x minus 3 and x plus 4. So I'm gonna put that there, but you go ahead and work out the left side to see if you can get the right answer. And then I want you to decide on what cancels out and what is the final answer. So if you put for the left side, if you had 2x minus 3 times x plus 9, you were right. So hopefully you did the AC method on this part. X squared plus 10x plus 9. Now is it necessary that we perform AC method? Not really, because you have a leading coefficient of 1 here. So I already know it's going to be x times x, right? So that's really the issue with AC method. You want to know what goes in this position, and AC method really helps you with that part of it all. Now I want to know what factors of 9 add to 10, right? That's pretty simple. Just 9 and 1. So now that we've factored everything, we can get rid of some stuff. We can get rid of the x plus 9s. We can get rid of the 2x minus 3. We can even get rid of the x plus 1. Now here is the million-dollar question. What is the answer to this problem? Because the x plus 4, notice, is in the denominator. That's why it should be in the denominator. It's not going to change back to the numerator. All right. And again, also, when we divide x plus 1 into x plus 1 again, remember, there's a 1 up here, there's a 1 up here, there's a 1 up here. We didn't write the 1, but think about it. That's really 1 times 1 times 1, right, in the numerator. And the denominator is 1 times 1 times 1 times x plus 4 in the denominator, for example. And so our answer is 1 over x plus 4. So that's our final answer. So always remember, if you cancel out all of this stuff, just know that there's a 1. The 1 exists in the numerator and the denominator, and there's no such thing as, oh, we don't have a numerator anymore. Okay, that 1 does exist. And this concludes the lesson on 6.2, multiplying and dividing rational expression.